All right, so we are back to, or continuing with the lesson on graphing tangent and cotangent functions. And so if you have not yet watched video 1, please do that, as some important information is first introduced there. Here we're going to look at the third example. And so with our third example here, we're graphing a cotangent function. Our 1 over b parameter is 1. The opposite of this minus 3 pi over 2 would be our c parameter, and our plus 1 is our k parameter. So when we go to graph the period, remember with tangent and cotangent, the parent functions have a period of pi. So we take pi and divide it by the 1 over b, the absolute value of that, which would be 1, and that gives us a period of pi. So here we are seeing there's not going to be a change in the period. It will be the same as the parent function. Our phase shift, though, we actually are going to see a phase shift here. So the opposite of this is our c value, and we take c, so that would be positive 3 pi halves, and we divide it by the 1 over b parameter, which again is 1, and that gives us a positive 3 pi halves. So what that is saying is that we have a phase shift, or horizontal translation, to the right 3 pi halves radians. So that means that the asymptotes for the cotangent function are both going to move 3 pi halves radians to the right. There will still be pi units between them because that period is the period of the parent functions. So what we're looking at here then is, when we go to graph this, we can put our x-axis pretty much in the middle. We do have a bit of a vertical translation. We do not have any vertical stretch, compression, or reflection across the x-axis, but we do have to make note that all our points are going to go up 1 unit. And for my y-axis, so cotangent, its asymptote begins at the y-axis, x equals 0 radians. It is then also going to move right 3 pi halves, so everything's going to push to the right. And so I am going to push my y-axis back a ways here. And for my x-axis, I am going to use pi fourths, because pi divided by 4 will give me pi fourths radians. So every 4 squares will be a multiple of pi. We'll have 3 pi, 4 pi, and that's probably far enough. For my y-axis, everything is moving up 1, but there's no vertical stretch, so I'm just going to use a scale of 1 unit. And, all right, so here we go, asymptotes. So what is happening with the first or leftmost asymptote here? So it's, for cotangent, the leftmost asymptote of the first cycle is the y-axis. So it is affected by translations to left and right, which would be phase shift. So it's going to move right 3 pi halves radians. So this would be 1, this would be 1.5, which is our 3 pi halves radians. It would be right here. Then pi radians further to the right, which is the period, we're going to have the asymptote that ends the first cycle. So this would be 1.5, so 2.5 pi would be the end of the first cycle. Remember, we have to graph 2 cycles of our functions. You can either graph the cycle to the left or you can graph the cycle to the right. If I move to the right, then the asymptote that ends the second cycle is going to be at 3.5 pi radians. All right, key points. So halfway between each pair of asymptotes is an intercept point. But we have to remember, we have this translation up 1 unit. So that 2 pi comma 0 is going to move up 1 unit and be right there. And 3 pi 0 is going to move up 1 unit and have a y value of 1. Then for cotangent going left to right, the y value of the point halfway between this intercept here and this asymptote, or what was an intercept, is going to be positive 1. So it was right here. That's our pi fourths and where it's moving. Pi fourths comma 1 is moving right here. And then it has to move up 1 unit for the value of k and ends up right there. This point, which had a y value of -1, also moves up 1 unit and ends up on the x-axis now. So this now has our curve. This is our concave up side going to positive infinity, concave down side going to negative infinity. And then that repeats in the next interval or next cycle. And we draw that curve in like so. And that would end that way. All right, moving on to the fourth example. So here, in this particular one, we actually have an A value of 0.5. Now that doesn't create what we call an amplitude, but it is going to create a vertical compression by that factor of 1/2. Then we have our 1/b parameter, which is 1. And then the opposite of this positive pi halves would be what we call c. And there's nothing added or subtracted, so our k is 0 this time, so no vertical shifts or translation. So for the period of this function, we're looking at taking pi because we're graphing tangent, dividing it by our 1/b, which is 1. So period is pi, same as the parent function, so that's not changing. So no horizontal stretches or compressions. Phase shift, though, we are going to have that. We have to take the opposite of this to get our c value. So negative pi halves divided by our 1/b value of 1 would give us negative pi halves. And that means that we're going to have a phase shift or translation to the left, pi halves radians. All right, so what that means to graph that first cycle is that with tangent, the leftmost asymptote is at negative pi halves radians. So it's going to move further to the left another pi halves radians. So I need to be able to get to negative pi to graph that cycle. I'm going to put my y-axis right around here. And again, I'm going to use that scale of pi fourths radians, because pi divided by 4 would give me pi fourths, so that's a good scale for me to use. So these are multiples of pi. And this way would be negative pi. My y-axis, I'm just going to go ahead and use a scale of 1 unit. I do have a compression, but I think it'll be easier to see if I use a scale of 1 unit, how it compresses, rather than changing my scale. All right, so now asymptotes. So, as we discussed, tangent is undefined at negative pi halves radians, which should be right here. So this asymptote is shifting left pi halves radians. So it's going another pi halves, which would take it to negative pi. So this is the asymptote on the left of the first cycle. Pi halves radians later, we're going to have the asymptote that ends that first cycle. And pi would be 4 squares. So that means the y-axis is going to be the end of that first cycle. To graph the second cycle, we go another pi, and this is going to be the asymptote that ends the second cycle I'm graphing. All right, halfway between each of those is going to be an intercept point, a y value of 0, and we have no k value to move it up or down from there. So we have these intercepts here and here. Now graphing tangent, remember left to right, the first y value is negative 1, and then the second one is the positive 1, so it moves this way. This vertical distance of 1 unit below compresses to half that distance, so it's now half that distance at negative 1/2, and the positive 1 distance compresses to a positive 1/2. And so our left side is concave down, right side is concave up. Make sure it shows it approaching its asymptotes. And then that repeats in the next cycle. Concave down on the left, concave up on the right. There's 2 cycles of this function. All right, and for example number 5. So example number 5 here is another tangent function. Here we have a negative in front, which we know means negative 1. So that negative 1 value for A means that we actually now have to remember we have an x-axis reflection. So the y values of positive 1 become negative 1, and the y values of negative 1 become positive 1. this structure right here, this, remember, means 1/2 times x, and then we have minus the pi fourths. And so this 1/2 is our 1 over b parameter, and the opposite of this minus or negative pi fourths, that is our c parameter. All right, so the period, we're graphing tangent, so we take pi and divide it by our 1 over b, which is 1/2. That would be pi times the reciprocal of that, which is 2, so we have a period of 2 pi. And remember that this 2 is actually what we call our b value, and that is greater than 1, so that tells us we have a horizontal stretch by that factor. The phase shift. So again, we need c. So we take the opposite of the minus or negative pi fourths, give us positive pi fourths. Then we have to divide that by 1 over b, which is 1/2. That would be pi fourths times the reciprocal, which is 2. And that simplifies to pi halves radians. And so that tells us that we're heading to the right because it's positive pi halves radians. All right. Here we go. So, graphing 2 cycles. So we're graphing tangent. The left asymptote of the first cycle is at negative pi halves radians, where tangent is undefined there. So it's going to be stretched horizontally, so it stretches to twice the distance multiplied by 2. So it's going to move to negative pi. And then it's going to move back to the right pi halves radians. So it's going to move to negative pi halves. Let me show you what that's going to look like. All right, so scale, if I take 2 pi and divide it by 4, that reduces to pi halves. So I can use pi halves, or if I wanted to go a little smaller than that and use my pi fourths, I could use that as well. I think I will just stick with, let's see, do I have enough space for pi fourths? That would mean 8 and 8, 16. Yeah, so I'm going to spread it out a little bit and use pi fourths radians. So that would make this, oh, actually, no, changing my mind. Let's use pi halves. So that would make this negative pi halves. No, with that, okay. Changing it again. I do like pi fourths. Use this, pi fourths radians is our scale. And this would be pi halves, this would be pi, 3 pi halves, 2 pi. That might be enough. And then we have our y-axis. I'm just going to use that scale of 1 again. All right, asymptotes. All right, so as I said, as we've talked about, tangent, first cycle of tangent, you have got asymptote at negative pi halves radians, where it's undefined. That distance, horizontal distance of 2 squares here, is going to double, right, your horizontal stretch factor, so it's at 4 squares here. But then it has to move to the right pi halves radians, and that would take it 2 more squares to the right. It actually ends up right back where it started in this case. But 2 pi radians later is where I'm going to find my second asymptote, and 2 pi would be at 1.5, so it's going to be here. And then I have 2 pi after that. So 2 pi is 2, 4, 6, 8. So 2, 4, 6, 8 right here. This is 3 pi. Oh, yeah, nope. 3, 4. So this is 3 pi. This is 4 pi. So when I'm looking at, for my asymptote, 2, 4, 6, 8, it's right there. Then halfway between them, I'm looking at my intercepts.